Alright, this lesson is for Friday, what we would normally do on Friday. What I'd like to do is turn to a clean set of pages in your notebook. On the left, you'll have page 53, and I'm going to do a quick review and reflect. I would go ahead and pause the video and take a minute to write down the two review questions and try number 1 and try number 2. And then also write down the reflection question, what makes a number imaginary, which is what this lesson is about. But let's pause the video. This is x to the third plus 5x squared equals x plus 5, and you're going to solve for x. And then number 2, x minus 1 times x plus 4 equals 24, and you're also going to solve for x. So pause the video and write these two down, try them, and then go ahead and play the video to see the solution. On number 1, we find our equal sign. We have a cubed term and a squared term. We're going to move everything to the left so that the cubed term stays positive. So we're going to subtract x and subtract 5. That's going to give us x to the third plus 5x squared minus x minus 5 equals 0. From there, we will factor by grouping. Because we have 4 terms, 1, 2, 3, 4, so we'll go ahead and group them off. That'll be x squared times x plus 5, and then from the second pair we're going to take out a negative 1, and then we have x plus 5 equals 0. This factors into x squared minus 1 times x plus 5 equals 0. Normally we're done and we can solve, but if you notice, we have x squared minus 1, and that is actually a difference of squares, and that factors into x plus 1 and x minus 1. And then we still have x plus 5 equals 0. We talked about in class, if you have a cubed function, you're going to have 3 solutions. And so from here, we should get the solution x equals negative 1, x equals positive 1, and x equals negative 5, all 3 solutions. On number 2, this is like the last couple examples we did in class on Wednesday. We're going to FOIL x times x, x times 4, negative 1 times x, oops, forgot the x. And then negative 1 times positive 4 is negative 4 equals 24. That makes x squared plus 3x minus 4 equals 24. We're going to move that 24 to the other side. That's going to give us x squared plus 3x minus 28 equals 0. Now we can factor. It's easy to factor because the leading coefficient is 1. We need 2 numbers that multiply to negative 28 and add to positive 3. And that would be positive 7 and negative 4. So we have x plus 7 and x minus 4 equals 0. And from there we can get our solutions. X equals negative 7, x equals positive 4. Now you can pause this video and watch that again if I went a little too fast. Otherwise, we're going to move on to the lesson. Make sure you write down the reflection question, what makes a number imaginary? Alright, so this lesson is from section 11.7 in your textbook. It is on complex numbers. We'll kind of ease our way into this. If you think back to chapter 11, the beginning of chapter 11, we said that the square root of negative 16 is a non-real answer. We didn't say it didn't have an answer, we just said it was a non-real answer. So the square root of a negative value is called an imaginary number, which sounds a little ridiculous right now, but it's not a real answer. It's what we call an imaginary number, and these are real and they are used in real life, but they're called imaginary numbers. we use the letter, it's a lowercase letter I, to represent an imaginary number. So we use the letter I to represent an imaginary number. Now the way I write this is lowercase, and I put a little hook on it so it does not look like a 1. So you want to make sure that clearly looks like a lowercase I, and it's usually kind of italicized so it doesn't get lost. The letter I represents the square root of -1. The letter I represents the square root of -1. It's very, very important to remember that piece of information. Anytime you see the square root of -1, we are going to write it as the letter I. Anytime you see the letter I, we have to remember that that's the square root of -1. It's a very important piece of information. This means if we have negative perfect squares, if we can remember this fact, negative perfect squares actually have a solution. So if I have the square root of -16, or the square root of -25, or the square root of -36, square root of -64, or the square root of -100, any of those, we notice that those are perfect squares. They have negatives on the inside. So the way we work these out is we separate them into the perfect square and the -1. So -16 comes from positive 16 times -1. -25 comes from positive 25 times -1. All of these, positive 36 times -1. Positive 64 times -1. They all work this way. Positive 100 times -1. And we're going to break these down very similar to how we broke them down at the beginning of chapter 11. The square root of 16 is 4, and we just said that the square root of -1 is going to be the letter I. So the square root of -16 is 4I. The square root of 25 is 5. The square root of -1 is I. And I know this is very strange. This little letter I is brand new. Your brain has never seen it before, so it's a little frustrated right now. The more we practice with it, the more comfortable your brain will get. So the square root of 36 is 6, and the square root of -1 is I. Square root of 64 is 8. Square root of -1 is I. Hopefully you're getting the hang of this. Square root of 100 is 10. Square root of -1 is I. So when you have a perfect square with a negative on the inside, you separate it into the positive perfect square and -1. The positive perfect square and -1, always. If we have non-perfect squares with negatives, we treat it the same as we did in section 11.3, which is on page 42 of your notebook. So when we have non-perfect squares, like the square root of -50, or the square root of -80, or the square root of -300, for these, we break them down just like we did in section 11.3. We think of the biggest perfect square, which would be 25, and the number it multiplies with, and then we still separate out that -1 as its own piece. So you do the biggest perfect square, the number it multiplies with, and the -1 is always by itself. Same thing for -80. It would be 16 and 5 and -1 by itself. We're factoring it out into the biggest perfect square, the number that multiplies with, and -1 goes by itself. Same thing here. 100 times 3, -1 by itself. And we do the same idea. The square root of 25 is 5. the square root of 2 stays the square root of 2, and the square root of negative 1 becomes I. We put the I in front of the radical, so it becomes 5I radical 2. If you remember from beginning of chapter 11, we do the radical last. So the correct way to write the answer is 5, which came from 25, I, which came from negative 1, radical 2 came from the 2. Same idea here. The square root of 16 is 4, and then the square root of negative 1 is I, and the square root of 5 stays the square root of 5. So 4I radical 5. Square root of 100 is 10. Square root of 3 stays the square root of 3. The square root of negative 1 is I. So it becomes 10I radical 3. The radical 3 goes last. The I goes in front of it, and then the perfect square all the way in the front. So perfect square, I left over. If you have values that don't have any perfect squares in them, like the square root of negative 5, or the square root of negative 7, or the square root of negative 10, if you have values like that, you separate just the negative 1 out and leave the 5 in. Separate the negative 1, leave the 7, separate the negative 1, leave the 10. For the square root of negative 1, we put I, and the square root of 5 stays under square root 5, so it becomes I radical 5. Makes me think of iRobot, I radical 5. And then again, the square root of negative 1 is I, the square root of 7 stays the square root of 7. Square root of negative 1 is I, square root of 10 stays the square root of 10. So because this is a video, you can pause and watch that again if that was a little too quick. Otherwise, we are going to move on to the next topic. So you can pause this video at any time. If you would like to try a couple of the problems before I go over them, that's a good opportunity to pause the video, and you can try it on your own. All right, I'm going to turn the page. If you need to turn the page as well, it'll be an example page. So I'm going to label mine example page. The product and the quotient rule are different for imaginary numbers. The product and the quotient rule are different for imaginary numbers. So the product rule, if I have the square root of negative 4 times the square root of negative 9, the original product rule says to multiply those together and you would get the square root of positive 36, but that's not how this works. So put a big X through that. That is not how this works. Instead, you break down each one of these separately. This becomes 2I, this becomes 3I, and then you multiply those together. And 2 times 3 is 6. I times I is just like X. It becomes I squared. And so I want to talk about I squared for a minute. We know that I is the square root of negative 1. So if I take I and square it, if I take this and square it, we know that a square cancels a square root, and you just get negative 1. So this is another very important piece to remember about imaginary numbers. I squared is always just negative 1. No more radical, just negative 1. And that's another very important piece of information to remember. You can put a star by that. I squared. Anytime you see I squared, you can change it to negative 1. So here we have 6I squared. This is really 6 times negative 1, which is negative 6, and that would be your final answer. So you get 6i squared, but you have to remember that I squared is negative 1, and that gives you an answer of negative 6. Let's try that again. If I have the square root of negative 16 times the square root of negative 25. You can pause and try it on your own, or you can just watch me. This is going to become 4i. This is going to become 5i. Together that makes, we're going to multiply those together, that makes 20i squared. Well, that's really 20 times negative 1, which becomes negative 20. Let's try it one more time. We have the square root of negative 3 times the square root of negative 5. All we're going to do is take the negative 1 out. So this is going to become I radical 3. This is going to become I radical 5. I times I is I squared. Radical 3 times radical 5 is radical 15. Now remember, I squared is negative 1, so it becomes negative 1 times the square root of 15, which is negative radical 15. So work these out carefully. Don't try to jump straight to the answer. I show these little steps on purpose so that you don't get lost. So same idea with the quotient rule. If we have the quotient rule, if I have the square root of negative 125 divided by the square root of positive 5, before I get started, I'm going to separate this out into negative 1 and 125. The negative 1 is going to become I radical 125. So the square root of negative 1 is I, and the square root of 125 stays there. And then divided by radical 5. I'm going to leave that I out front. I'm going to turn this into the big square root of 125 divided by 5. That becomes I times the square root of 25. 125 divided by 5 is 25. And you have I. And this becomes the square root of 25 is 5, and then I. So if you need to see that again, go ahead and go back in the video and watch that again. You always break down your negatives before you start simplifying. Clean up your negatives, pull your i's out. That's what I always say, pull the i's out, which sounds kind of funny. Then use whatever the rule is. Alright, let's try that one more time. If I have the square root of 81 over the square root of negative 6. To clean this one up, I'm going to look at the bottom, pull out the negative 1. This is going to become the square root of 81 over I radical 6. And again, that's because the square root of negative 1 becomes I, and the square root of 6 stays the square root of 6. Now I know the square root of 81 is 9 over I radical 6. We learned at the beginning of chapter 11, or towards the end, that we need to rationalize this because we can't have a radical on the bottom. So I'm going to multiply the top by radical 6 and the bottom by radical 6. This is going to give me 9 radical 6 divided by 6i. Remember, a radical times itself. So radical 6 times radical 6 is just 6. From there, I'm going to reduce 9 divided by 6. This is going to give me 3 radical 6 over 2i. We're almost done. From here, just like we can't have a radical on the bottom, we also cannot have I on the bottom. So I needs to also be rationalized. So we're going to multiply the top by I and the bottom by I. So anytime you have an I on the denominator, you have to do this. This is going to give me 3i radical 6 over 2i squared. So you treat the I just like a variable. We're going to put this in front of the radical, and I times I is I squared. Well, we just learned that I squared is negative 1, so it's 3I radical 6 over 2 times negative 1. This is 3I radical 6 over negative 2, and that craziness is your final answer. So you really have to baby step your way through these one piece at a time. Only do what you know to do. Don't try to do multiple things at once. Some of these require a lot of little baby steps to get to your final answer. You cannot have a radical on the denominator. You cannot have an I on the denominator. So keep that in mind as you go through. Also, always remember that I squared is negative 1. That will come in handy in the next part of this. I'm going to pause the video there so that it doesn't cut me off, and then I will continue recording in just a second.